This example is going to illustrate how we simplify radicals as well as combine like radicals. Now, earlier you had seen that the perfect squares are extremely important. So to list these numbers again, we find them by, if we don't know them ourselves, if we didn't memorize them, we can always find them. The first is 1 squared, which is 1. The second is 2 squared, which is 4. 3 squared, which is 9. 4 squared, which is 16, 5 squared, which is 25, and as I said before, this list goes on forever. And again, these are some special numbers in mathematics that you should know. You should get a grasp on them and love them like I do. So 1, 4, 9, 16, 25, 36, 40, 49, and so on are the perfect squares. So once we have the perfect squares, what we want to do is use them to simplify these square roots. Now, in order to find a simplification of the square root of 75 and the square root of 12, what we have to do is apply a rule which states that if you have any two numbers that multiply together underneath a square root sign, this is equivalent to breaking them up into two separate radicals. And we're going to apply this property with each of these. But one of these factors that we have, a or b, we want to make a perfect square. Because we know the square root of 4, which is 2. We know the square root of 9, which is 3. We know the square root of 16, which is 4, and so on. So how would we find this? Well, how do we know what the factors are that will work beautifully for this? Well, what we want to do is divide each of these perfect squares into this number until it works perfectly. So if you have your calculator, you would take 75 and divide it by 4. We don't get an integer. Therefore, we know that that's not two factors that we can use using this rule. If we divide 9 into 75, again, not an integer. 16, but 25, we see 25 goes into 75. So if we write that perfect square first, and that's going to be important when we simplify, because we like to have that integer, once it's simplified as a square root, in front of the radical sign. It helps with clarity in a little. So now we want to do the same thing here. So we still have our plus 7. How would we reduce to 2 factors 12 when we know one of the factors have to be on this list? And again, we could do 1 into 12. It doesn't help us. 4 goes into 12 3 times. That's perfect. And again, we want to write that perfect square first, because when we simplify this, we want to have that term in front of the radical. So now we just do what we're asked. So this reads the square root of 25, which we know is 5. And this is being multiplied by the square root of 3. And then we're adding 7 times the square root of 4, which is 2, times the square root of 3. Now here we can see there's a little simplification we can do. The 7 times 2 is going to be 14. So again, structure is fantastic in math. So you want to use it as often as possible. Don't be lazy. Write out the line. And now we see that this term, 5 square root 3 plus 14 square root 3, these two terms are like terms because they have the same base and the same index. Here we understand that the index isn't written because it's 2. And mathematicians sometimes like to cut corners, so you'll understand that. So here we have 5 of these things plus 14 of these things. So in total, we have 19 of those things, the square root of 3. And this represents the simplification of the square root of 75 plus 7 square root 12. So a second example we're going to do is not with square roots, but now cube roots. And as we had done before, we want to make sure we know the perfect cubes. So our perfect cubes are 1 cubed, which is 1, 2 cubed, 2 times 2 times 2 is 8, 3 cubed, which is 27, 4 cubed, which is 64, 5 cubed, which is 125, and so on. Again, just like the perfect squares, the perfect cubes are numbers that are really essential to simplifying these examples. Now, just like our simplification of finding what perfect square worked here, we're going to use the same logic here. What is the number that would work best? What factor? Now, we could have 6 and 4, but notice 6 and 4 are not perfect cubes. So that wouldn't reduce well for us, as the square root of 25 did in this example and the square root of 4 did in this example. So we want to find whether 8 or 27 or 64 or 125 is a perfect cube, which is a factor of this number or this number, so that we can simplify it. So if we take 24 and divide it by 8, we can see that that is a factor which also has 3 in it. So we rewrite this using the product property. So the cubed root of 8 times the cubed root of 3, again, write the perfect cube first for simplification reasons, subtracted by 4. Now, how do we find what number of a perfect cube is a factor of 81? Again, take out your calculator if you need it. 8 does not go into 81 evenly as an integer, so we know that that's not going to work for us. 27 divided into 81 is 3, and you can check that on your calculator. 81 divided by 27. So we can rewrite this as a product of two factors of the cubed root of 27 times the cubed root of 3. Now this is already in its simplest form, so we would simply rewrite that component. And now, as we did over here, what is the square root of 25? 5. What is the cubed root of 8? Well, the cubed root of 8 is 2. So we have 2 times the cubed root of 3 minus 4. The cubed root of 27, the reason we chose that as a factor is because it's a perfect cubed. That equals 3. And then we're going to be multiplying that by the cubed root of 3. Notice each one of these align with the term that it is. It's very linear in this type of question. And that equals this. And again, we have a simplification here which we can simplify. So we have the cube root of 3 times 2. This is 4 times 3, which is negative 12, times the cubed root of 3. Plus 1 is understood out here. I'm going to put that 1 in there just so we can see it. And as we did in the other example, we have 2 of these things. We have negative 12 of these things, and we have 1 of these. When we combine all of those together, we have 2 minus 12, which is negative 10, plus 1, which would give us negative 9. So we have negative 9 cubed root of 3. And that's our simplification. Enjoy.